Hello, my name is Adrian, and I'm an engineer here at Keysight Technologies. In this video, we will be going over an example of troubleshooting a wireless LAN signal that doesn't demodulate properly using Keysight 89600 VSA software. When troubleshooting, there are three key analysis techniques that when put together can form a troubleshooting process as observed in this diagram. In this video, we will be looking at basic frequency and time measurements to make sure there isn't a fundamental problem before attempting advanced troubleshooting. Here, we are looking at a signal. Based off the spectrum, it appears to be a proper 802.11a signal, observing that its occupied bandwidth is around 16.5 MHz, which is near what's expected out of this format. However, the VSA software can't demodulate the signal. This tells us that there is something wrong. The first thing we need to do is switch to vector mode. This enables us to look at the signal in the time domain. To do this, go to Measurement Setup, Measurement Type, Vector. Next, we need to adjust our settings so that we can see a good representation of the signal. Auto-range the signal. Adjust the trigger settings properly to be able to view a stable signal that's easy to read and interpret. These settings will vary depending on the signal. Now that we have these set, let's take a close look at the signal. It is important to be familiar with the format of the signal you are analyzing. For an 802.11a OFDM burst, the preamble contains an 8 microsecond short training sequence and an 8 microsecond long training sequence. This is followed by a 4 microsecond signal symbol, and then come data symbols of 4 microsecond blocks. This means that we can set our time to be 24 microseconds in order to see from the beginning of the burst up through one data symbol. We can change this by selecting Measurement Setup, Time, Main Time Length. Next, we can set up a time gate to make sure a signal matches the defined structure. Set the gate to a length that makes the most sense. In this example, since the structure of the burst contains blocks of length with a common factor of 4, the ideal length for the gate will be 4 microseconds. This can be done through the Time menu under Measurement Setup. Now that there is a gate set up and the different sections of the signal burst can be identified, we can measure the length of these sequences to see if they match the defined structure. The gate, which now has a set length of 4 microseconds, can be moved around by clicking and dragging on the left end of the gate. Matching the gate to the short training sequence, we can see that this is only about 4 microseconds, nowhere near the 8 microseconds required. We have identified a problem. Let's continue to see if that's the only time measurement issue. Moving to the right, the long training sequence is around 8 microseconds, the signal symbol is around 4 microseconds, and then the rest is data. This looks correct. Therefore, we can conclude that the issue is that the preamble is not long enough. This now gives the direction for fixing the issue. For example, this tells us that an amplifier probably didn't turn on quickly enough. Once the issue is fixed, we can look at it again. We now observe that the short training sequence is 8 microseconds as expected, and all of the other sequences also behave as expected in the time domain. Now, we can check if the signal can be demodulated. Everything looks great and behaves as expected. If this technique didn't lead to any discoveries, the next step would be to do advanced demodulation troubleshooting. Thank you for watching this video. For more information on any of the topics mentioned in the video, please consult VSA Software's help files.